Alright, here's one with decimals. We look at the decimals. I'm going to notice that I could do this distribution now, but what I'm going to do is treat these three terms as, well, these are three terms. If I multiply both sides of this equation by 10, multiplying this by 10 takes care of all of this, because 10 times 0.3 times whatever's in here, that takes care of the distribution. Likewise, I can multiply 10 by this one and 10 by this one. In doing so, I now have 10 times 0.3 times 3x plus 1. And that's just like when we had the 2 times 3 times 4. We can multiply the first two terms together and just leave that binomial alone for a little bit. So 10 times 0.3 gives us a 3, and then the binomial that we're going to multiply here in just a minute goes along for the ride. Minus 10 times 0.2 is 2, and the binomial that we're going to multiply goes along for the ride. And 10 times negative 0.9 is negative 9. Alright, we've got our first set of distribution to do, so we need to do some distribution. We'll share this 3 with everybody, share this negative 2 with everybody. 3 times 3x is 9x plus 3. Whenever you're distributing or doing a distribution, make sure you take the sign with the number. So negative 2 times 7x gives us a minus 14x. And you're all going, yeah, well, I saw that. But what a lot of people miss is that negative 2 times negative 4, that's going to change this sign, turn it into a positive 8 or a plus 8. So don't forget to bring this negative through when you multiply by the second or if there are more terms. Combining our like terms, we've got 9x and a negative 14x gives us negative 5x. We've got 3 plus 8 gives us 11. Alright, now we want to get all our x's on one side, all our non-x's on the other. This 11 is a non-x, so let's move it away from the x's. We'll do that by subtracting, and we're allowed to subtract from the left side as long as we also do the same subtraction from the right side, giving us negative 5x equals negative 20. And I can already see I'm running out of room. Negative 5x equals negative 20. We'll divide both sides by negative 5 because we want it to be a positive 1x. And when we do that, the negatives and the 5's divide out. We're just left with x equals positive 4. And if we go back to our original, we get 0.3 times, I'll shortcut this a little, 3 times 4 is 12 plus 1 is 13. So 0.3 times 13 minus 0.2 times 7 times 4 is 28 minus 4 is 24. And we hope that is equal to negative 0.9. 3 times, or 0.3 times 13 is 0.39. 0.2 times 24, I'm sorry. 0.2 times 24, that should be 3.9. That's going to be 4.8. And that is indeed negative 0.9. Next one. 7x plus 2 equals 7 times the quantity x plus 2 equals 5 times the quantity x minus 2. plus 2 times the quantity x plus 12. Distribution, 7x plus 7 times 2 is 14 equals more distribution, 5x minus 10 more distribution plus 2x plus 24. Alright, we've got some like terms on the right side. We get 7x plus 14 equals 7x plus 14. Well, that looks a little odd, but let's follow it the rest of the way through. We want all of our x's on the same side, so I'm going to take these 7x's away, and that's okay as long as I do the same thing on the left side. And my 7x minus 7x, if I've got 7 of something and I take them away, I don't have anything. So that just gives me a 14 on the left side. And on the right side, we also end up with a 14. Now, where did our x's go? How are we going to deal with this? If all your x's go away, if your variable disappears on you, and you're left with a true statement, like 14 equals 14 or 0 equals 0, then your original equation is an identity, meaning anything you want to put in there for x will satisfy the equation. You can put in 7, 142, 312 million, whatever you want to, 7,427.3. Anything you put in there will make it true. So we say that the solution to this is all real numbers, and we also sometimes write that as the all real numbers are, or negative infinity to positive infinity in interval notation. Next one, 3b minus 3 times the quantity b plus 1 equals 5 times the quantity b minus 1 minus 5b. So distribute, and when we do, make sure and remember that negative goes with the 3. 3b minus 3b minus 3 equals, we'll distribute the 5, 5b minus 5 minus 5b. Combine our like terms. 3b minus 3b is 0b, or just 0, so that goes away. 5b minus 5b, likewise, just left with negative 3 equals negative 5. Now, when you've got all of your variables, when all the variables disappear and you end up with a statement that is not true, I mean, this is false. Negative 3 is not equal to negative 5. Whenever that happens, that means we have a contradiction. No matter how creative an answer we come up with, we could try square roots, radicals, imaginary numbers, it does not matter how creative we are, there isn't any x or b or whatever your variable is, there's nothing you can do to come up with the correct answer. So we say that there is no solution. And sometimes we indicate that with an empty set symbol.